5 million crackers, every hour, every one of them with a face. But here's the crazy part. That face, the smile, the eye, the fin, isn't printed on after baking. It's stamped into dough at 1,500 crackers per second, with a tolerance measured in thousandths of an inch. That's one Goldfish cracker for every man, woman, and child in the United States. Every single day. Today we step inside Pepperidge Farm's production line to expose the precision engineering behind the world's most recognizable cheese cracker. The world's most recognizable cheese cracker. But before the machines, there was a man and a birthday present. The Swiss love story. 1958 Switzerland. Baker Oscar Kambly II wants to give his wife something unique. She's a Pisces, so he designs a cracker shaped like a fish. Not a goldfish, technically, just a fish. A small, savory biscuit, based on a traditional Swiss recipe, cut into the shape of her astrological sign. He calls them Goldfishly. They become a local hit, a charming, affectionate product created for an audience of exactly one. Then, in 1962, American businesswoman Margaret Rudkin walks into a Swiss shop and sees them. Here's the context you need on Rudkin. She is already a legend by this point. She founded Pepperidge Farm in 1937 after her son's asthma led her to obsess over preservative-free bread. She built a baking empire from scratch, from a farmhouse kitchen in Connecticut at a time when homemade-style bread had no real commercial market. When she sees Goldfishly in that Swiss shop, she doesn't see a charming local biscuit. She sees a billion-dollar idea. She brings the recipe to the United States. She rebrands them as Goldfish. And what began as a romantic gesture in a Swiss bakery becomes the most recognizable cheese cracker on the planet. But here's where it gets even stranger. The thing that makes Goldfish iconic isn't the fish shape, it's the smile. And engineering a smile onto 1,500 crackers per second, consistently, repeatably, at zero failure tolerance, isn't baking. If you want to know what's really in your food, subscribe. We go inside a new factory every week. It's precision manufacturing. The engineering challenge. Here's the problem that most people never stop to think about. At home, you roll out dough, press a metal cutter down, lift, the shape stays. Now scale that up. Goldfish don't use individual cutters. They use a continuous rotary die, a massive engraved metal cylinder spinning continuously against a moving sheet of dough. As it rolls, hundreds of fish-shaped blades cut through the sheet in a single motion. But here's the engineering question that actually matters. How do you emboss a face, a smile, an eye, a fin contour onto a cracker barely 2 millimeters thick, moving at 1,500 units per second, without tearing the dough or losing the detail? The answer is that the die cuts and stamps simultaneously. Each cavity in the cylinder contains a complete negative mold of the entire goldfish, body, fin, eye, smile, engraved to less than 3/1000ths of an inch tolerance. Too deep, and the dough tears at the edges before it can release cleanly. Too shallow, and the smile doesn't transfer with enough definition to survive the baking process. It has to be exactly right, every rotation, across a dough sheet that is constantly moving, constantly stretching, with variable moisture content that changes with ambient humidity in the facility. That is not a cookie cutter. That is a zero-failure precision instrument running at the output rate of an industrial machine. Inside the factory, dough-to-bag pattern interrupt. Let's follow one goldfish from raw ingredient to sealed bag. The dough is built from wheat flour, real cheddar cheese, salt, yeast, and a precise spice blend. The cheese isn't powder applied as a coating. It's mixed directly into the dough at a concentration high enough that Goldfish legally classifies as a cheese snack rather than simply a cracker. This distinction matters on the label, and it matters in the eating. The cheese flavor comes from the inside of the cracker, not a dusting applied to the surface. Mixing happens in batches of several hundred pounds at a time. Then a sheeting system rolls the dough to exactly 2.1 millimeters. Not 2.3, not 1.9. The thickness determines everything downstream: baking time, final texture, and whether the rotary die can stamp the face cleanly without tearing. Then the rotary die itself, a cylinder roughly the diameter of a car tire. Each full rotation stamps and cuts hundreds of fish from the moving dough sheet simultaneously. The excess material between the cut shapes, called web or lace, is pulled away continuously and recycled back into fresh dough batches. Zero waste. After cutting, A 200-foot tunnel oven at 550 degrees Fahrenheit, but not a uniform 550 degrees. The oven is zoned. Lower temperatures in the early sections to set the shape without collapsing it. Higher heat in the middle to develop the gold color and the crunch. A slight cool-down zone at the exit to prevent thermal cracking as the cracker transitions from oven hot to ambient temperature. The baking is not simply cooking. It is thermal engineering with a defined outcome. A specific color, a specific moisture content, a specific structural integrity that must be reproduced identically across every batch. After baking, a seasoning drum, a rotating cylinder that tumbles the crackers through a micro-thin coating of salt applied by a calibrated spray system. Drum speed, the angle of internal baffles, the spray pattern, all are tuned so that every individual cracker receives statistically identical coverage. A cracker with slightly too much salt or slightly too little salt fails the consistency standard that defines the product. Then the optical sorting system. High-speed cameras scan every cracker as it moves through the line, evaluating for broken pieces, undersized fish, and smeared or incomplete face impressions. Rejected crackers are removed via compressed air jets, targeted with enough precision to pick individual pieces off a moving belt without disturbing the surrounding product. Only perfect ones proceed. Finally, multi-head weighers portion the crackers to the exact specified weight before they drop into bags that are flushed with nitrogen gas before sealing. The nitrogen displaces oxygen inside the bag, preventing the natural oils in the cheddar cheese from oxidizing during shelf storage. The bag isn't just packaging, it's a preservation environment designed to maintain the product for months without refrigeration or artificial preservatives. Here's what I want to know from you. Goldfish have had the same smile since 1962. The shape hasn't been redesigned, the face hasn't changed. In an industry that rebrands every 3 years, that's unheard of. Is the Goldfish smile timeless brand genius, or just a cracker that got lucky? Drop your answer in the comments. I read everyone. Let me bring this full circle. The smile on a Goldfish cracker is not a marketing gimmick. It's a manufacturing signature. It exists because in 1958, a Swiss baker wanted to make his wife happy. And it persists because in 1962, an American businesswoman understood something the cracker industry hadn't fully articulated yet. A cracker with a face isn't just a cracker, it's a character. And characters create loyalty in a way that a flat, anonymous biscuit never can. Think about that for a moment. The entire competitive advantage of the most successful cracker in American retail history is rooted in a romantic gesture made by one man for one woman in a country most of its eventual customers have never visited. Campbell Soup Company, which acquired Pepperidge Farm in 1961, just 1 year before Rudkin introduced Goldfish to the American market, invested $160 million in a new production facility in Utah that opened in 2024. 5 million crackers per hour, 50% more capacity than what came before. Enough additional output to cover the equivalent of another country's entire snack cracker demand, added to a production line that was already the largest of its kind. But the smile is still stamped with the same precision, the same tolerances, and the same rotary die principle that Oscar Kambly used in his Swiss bakery, scaled up by a factor that would be incomprehensible to him. 55 million pounds of Goldfish crackers per year, each one 2 millimeters thick, each one stamped with a face that required an engineering solution no off-the-shelf equipment could provide, each one looking back at you from the bag with the same expression it has worn since the year John F. Kennedy was in the White House. Tiny crackers, massive precision, one smile at a time at 1,500 per second. Subscribe for more deep dives into the engineering behind the world's most iconic products. And if this surprised you, if the precision required to stamp a smile onto a cheese cracker was not what you expected, you need to see what they're hiding in the Parmesan industry. That video is on your screen right now.